All right, let's keep going on. Second to last, penultimate problem. If a continuous density that never touches the horizontal axis is symmetric about 0, can we say its associated median is 0? So this is a little bit of an unfair problem, and if you didn't get this, certainly don't feel badly about it, and I'll tell you why. So here we have a density, and here I've said it never touches 0, and it's symmetric about the vertical axis. So what that means is if I draw it like that, then it has to look like that on the other side. If I were to draw something like this, let me see if I can, it's got to look like that on the other side. And so to me it looks pretty clear that this density has to have median 0, because the amount of area that's on this side has to be the same as the amount of area on this side because it's flipped over, it's symmetric. Now the reason about the sort of rigmarole in the problem about never touching 0, and that's what makes it confusing, and I think that's why it was a little bit of an unfair problem. I had it in the actual quizzes at one point, and it caused a lot of problems. So now I put it in the homework, so at least we can discuss it. And some of the students, when I put it in the homework, I had it without this caveat that the density had to be touching 0. And students came up with this example, which is really clever, of course. Well, imagine a density that looks something like this. Okay. Now, here it's strictly 0 right here. Here's 0. Now remember, what's the median of a density? The median is that point such that 50% lies below it and 50% lies above it. Well, this, I didn't draw it perfectly, but I'm trying to suggest that this and this are mirror images of each other around this vertical axis. But it's 0 in between. So any point along between here, any point between where the densities start rising above 0 again, any point would be such that 50%, because right, 50% lies there and 50% lies there. So any point in here would be a median. And they all said, well, how do you define the median in that case? Is it necessarily 0? Is it the midpoint of all the potential medians in there? Or is it the leftmost median? Or is it the rightmost median? And that was kind of confusing. But I also thought it was an incredibly clever point made by many of the students in the class. So I thought I'd raise it up and give it as one of the homework questions, so at least we could discuss it. So I'm going to put yes here and submit, and then I just want to show you the answer because I actually go through some of this discussion and I actually put in that this is a surprisingly hard problem. It seems my intention was for it to be an easy problem. My original intention was, yes, if a density is symmetric about 0, then its median is 0 because 50% lies below 0 and 50% lies above 0. But there's this caveat that if it's flat on the horizontal axis right around 0, then, well, that causes problem. So I described this caveat a little bit in the homework problem. And if you miss this little kind of subtle point of nuance, I mean, this is really not a major important point. What I'm hoping you'll know is what a median is. Basically, what does it mean for a point to be a population median? And it's just that point such that 50% of the density lies below it and 50% lies above it.